Hello, and welcome to this brief tutorial on the three main types of water purification methods used in the home: filters, reverse osmosis systems, and distillation systems. Filters are the most common type of water purification used in homes today. Filters are a barrier method, which means a barrier is placed in front of your water, water flows through it, but some of the contaminants are too big to pass through the filter, so they remain behind. Filters can be made out of many different substances and can be targeted to remove specific things. The most common filter substance is activated carbon. It does a decent job of removing organic compounds. Organic compounds are typically going to have a taste or odor, and they're usually one of the things you want to remove. Filters are also relatively cheap. The most common way to create an activated carbon filter is to take a piece of coal, sometimes coconut, and pressure heat it to up to thousands of degrees. All the different elements inside the coal will vaporize and burrow their way out of the carbon. You now have a piece of carbon with a bunch of nooks and crannies inside of it. Water flows through these nooks and crannies and then flows out, but contaminants will get caught inside these channels and will be unable to leave. This is how a carbon filter works. Once those spaces are full, your filter needs to be replaced because they will clog. These filters are commonly used as pitchers filters or even faucet filters. What are the drawbacks of filters? Your quality of water will drop as the carbon becomes less effective. A common phrase you will hear about the filter is that it will remove the bad contaminants but leave the good minerals. There's no way for a filter to differentiate this. The removal rate is strictly based on the size of the channels in the carbon for the contaminants to get caught in. Also, your water may taste or smell better, but could still contain lead, nitrates, cesium, or even viruses. The next type of purification method is reverse osmosis, or RO. This is essentially a series of filters where water is pushed through under pressure. RO systems use a semi-permeable membrane. In order to understand reverse osmosis, you're first going to have to understand osmosis. Osmosis occurs when you have two pools of water connected by a semi-permeable membrane. That allows water through, and water will seek to balance itself. If the contamination levels on each side are different, it will seek out balance by moving water from the less contaminated side to the more contaminated side so that the pressure and contamination percentages become equal. In other words, osmosis moves water from high purity to low purity. You can then guess how reverse osmosis works. By supplying external pressure on the contaminated water side, you can force the water to move through the semi-permeable membrane into the purified water side, leaving the contaminants behind. What are the drawbacks of an RO system? First of all, it is a filter. Filters eventually deteriorate and need replacement. With so many filters in an RO system, the maintenance expense can be quite costly. Second, RO systems can waste water. Some residential systems can waste water up to 10 gallons just to produce 1 gallon of purified water. Another big drawback is bacteria. Bacteria can build up on the contaminated side of the semi-permeable membrane. These colonies can then pass through the membrane in what is known as bacteria creep. RO systems are better than filters, but not the most ideal solution. The final form of purification I would like to discuss is distillation. Distillation mimics the hydrologic cycle that nature uses to purify water. The sun heats up the water on the ocean until it becomes water vapor and rises into the air. Once it gets high enough, it begins to condense and form clouds. Then it falls as rain to replenish oceans, rivers, and streams. If there were no air pollution, rainwater would be 99.9% pure. That's also what you get from a high-end distiller. Tap water is heated inside a boiling chamber to the boiling point. Purified steam rises up from the contaminated water, leaving the particulates behind. The steam moves into a cooling coil where it is run over a fan that cools the steam back to liquid. From there, it flows into a glass jar or stainless steel holding tank. Unlike barrier methods that remove contaminants from the water, distillation removes the water from the contaminants. Essentially, Anything that has a higher boiling point than water will remain behind inside the boiling tank to be drained away later. There are some contaminants with a lower boiling point than water that will rise up with your steam. These are called volatile organic compounds, or VOCs. Our distillers have patented dual vents on the cooling coil to vent off these VOCs, and should they condense down with the steam, they will be removed with the filter. Distillation is also the best way to deal with bacterial and viral contamination because it boils the water, which kills the bacteria and viruses, and because they can vaporize, the dead bacteria and viruses remain behind in the boiling tank. Distillation is also consistent. Filters and RO systems lose effectiveness as time goes on. Distillation will give you a consistent removal of contaminants, whether you're using the distiller for the first time or 20 years later. You should still get the same high purity water. Distillation is the gold standard when it comes to water purification. I hope you've enjoyed this tutorial and learned something. If you have any more questions, please feel free to contact us at Pure and Secure. My number is 1-800-875-5915, extension 310.